Use your knowledge of asymptotes and intercepts to match the equation. F of x equals 36 over x squared minus 36 with one of the graphs that follow. List all the asymptotes. Check your work using graphing calculator. Okay, so we have many questions here actually. So let's do some analysis about the asymptotes, vertical asymptotes or horizontal asymptotes and oblique asymptote. So how to determine, so let's start by the first one. How to determine, number one, vertical asymptotes. Vertical asymptote. How do we determine the vertical asymptote? Okay, for the rational function, for irrational function, f of x equals p of x over q of x. And both p of x and q of x are what? Are polynomial. With no common factor. So these are polynomials and they don't have any common factor other than the constant. The constant. The constant doesn't change anything. Okay? If A is a zero of the denominator, then the line x equals a is a vertical asymptote. Is a vertical what? Asymptote. For what? For the graph of the function. For the graph of f of x. Asymptote. Asymptote. What does it mean by the vertical asymptote? It means something that if f of x goes to infinity, as x goes to certain value a here from the left or from the right, or f goes to the negative infinity as x goes to the certain value as a from the right or from the left. And we're going to see this in the graph. So the idea is we need to look at the polynomial. The polynomial and check. Let's look at the polynomial. This is the polynomial. 36 over x squared minus 36. So this is p of x here. This is p of x. And this is a q of x. And it's clear that we don't have any common factor among these two polynomials, right? The vertical asymptote says you need to look at the q of x and equate it to 0. Look at the 0 of the denominator. So q of x, set q of x to 0. What is a q of x? It's x squared minus 30x, minus 36. Equate it to 0 and solve for x. When you solve for x, what are you gonna get? Are you gonna get, solve for x using square root property or difference of two squares as you like. So I'm going to solve it using square root property. So positive 36 to both sides. Then I'm going to take square root to both sides. Remember, when you take square root to both sides, you get positive and negative zeros, two zeros. So the square root cancels with the 2. We get x here. And there we're going to get positive and negative 6. So we have two vertical asymptotes now. So this is the first analysis. The second analysis, we need to look at the horizontal asymptote. The horizontal asymptote. What does the horizontal asymptote say? To test whether we have a horizontal asymptote, here number 2, horizontal asymptote. What are the tests of the horizontal asymptote? If, number A, this is A, if the degree of P of x is equal to the degree of Q of x, then the horizontal asymptote, is y equals a over b. What is a? What is b? A is the coefficient, is the leading coefficient of P of x, and B is the leading coefficient of Q of x. This is the first case. The second case, B. If the degree of the numerator is less than, if the degree of P of x is less than the degree of Q of x, then what? Then the horizontal asymptote is what? Is y equals to 0. C. If the degree of P of x is greater than the degree of Q of x, then there is no horizontal asymptote. There is no horizontal asymptote. Okay, let's look at P and the Q here. What is P and the Q in this example? What is the degree of the P? The degree of the P is 0 now, because we have a 0 or we have a constant function. P of x is 36, okay? Is only 36. So it's a 0 degree polynomial. The Q of x has a second degree. So P of x has a degree of 0, Q of x has a degree of 2. So which one applies? 2, B, right? So P is the one that we are looking for, because the degree in this example, P is 0. The degree of a Q is 2. Then the horizontal asymptote is y equals to 0. Good. So now we have what? We have two vertical asymptotes. We have x equals, the first line is x equals to the negative 6 and x equals to the 6. These are two vertical asymptotes. And we have one horizontal asymptote, which is y equals to 0. So we have two vertical lines and one horizontal line. Okay? Do we have an oblique? No, because we have a horizontal asymptote. We cannot have both oblique and horizontal asymptote. Because we have a horizontal asymptote, then there is no an oblique asymptote. So let's look at the graphs now. Okay, which one of these guys contains two vertical asymptotes? It's clear that B. B has two vertical asymptotes, and the first one at 6, this is 6, this is negative 6. So this line is x equals 6, this line is x equals to the negative 6. What about the horizontal asymptotes? Yes, there is a horizontal asymptote because this line goes to the infinity here. You see that? This guy goes to the infinity. It doesn't touch the horizontal asymptote. Where is the horizontal asymptote? Is this one. Y equals to 0. Y equals to 0. Okay? Which is the x-axis actually. Which is the x-axis. So probably B is going to be the answer. A is not the answer because only we have one vertical asymptote here, so this is wrong. Okay? What about C is also wrong because we have only one vertical asymptote. In B we have two vertical asymptotes, so B is going to be the solution. So where is the question? Where is the answers now? So the function has one vertical asymptote. This is wrong. The function has two vertical asymptotes. Yes. The left one is x equals to the negative 6, and the other one is x equals to the positive 6. The other one, determine the oblique asymptotes. We don't have oblique asymptote. A. Why? Because we do have horizontal asymptotes. So which one we're going to pick from A, B, C? The function has one horizontal asymptote. Correct. Y equals to 0. Okay? Perfect.